Hi, this is Dr. G. Vikas Paul. In this session, we'll discuss about the approximate method of analysis in the structural analysis 2 subject. So, coming to introduction, in the case of multi-story frame, the degree of indeterminacy is very high. So, we know this. The solution of a slope deflection method, column analogy, moment distribution, and Carney's method is ruled out. So, Carney's method requires more computational efforts, that is, dead loads and live loads. So you can see the multi-story building here, multi-story frame with live loads, dead loads, and horizontal forces, lateral forces also, earthquake loads, vertical loads. You can see in this figure. So in this type of structure, both dead loads and live loads act together, constituting the vertical loads. The dead loads act through dead loads and live loads will act on each beam as well as column. The dead loads acts through the frame at all the time. Dead load will be there all the time. The live loads acts through the frame at a particular time. Live load will act at a particular time only. So lateral loads on live loads are live loads that are lateral loads are the live loads that are applied parallelly. So these are the lateral loads to the girder, parallel to the girder. That is, they are horizontal forces acting on the structure. So these are the lateral forces, these are the vertical forces. So any force may be there on the multi-story frame, lateral forces, vertical forces, etc. And dead loads, live loads will be there. Dead loads will act always on the frame. Live load will be acting particular time only. So for the horizontal forces, for the multi-story frame subjected to horizontal forces, we have three methods to analyze, three approximate method of analysis. They are portal method, cantilever method, and factor method. For vertical loads, that means if there is no horizontal force, only vertical loads are there, then substitute frame method is used. So first of all, we'll see the very first method, that is portal method. That is for horizontal forces, multi-story frame subjected to horizontal forces. So for portal method, using portal method analyze the frame shown in the figure. So this is a multi-story frame given, spans are given 4, 6, 4 meter, 3.5, 4.5 heights of first story, second story, first story, second story. So 40 kN horizontal. So horizontal forces are there. Therefore, we can use any of the three methods. That is portal method, cantilever method, and or factor method. In this method, we will see the portal method steps. So steps in portal methods are: first step is calculation of horizontal shear in the column. Step 2, moments at the ends of the column is to be calculated. Next, in step 3, moments at the ends of the beam is calculated. Shear in the beam is calculated. Then finally, axial forces in the columns are calculated. So first of all, we need to find the column shear forces. Yeah, if you see here, story 2, we have drawn here only story 2, this part. Then here, story 1. Story 1 means, so here story 1 is to be considered. So I will explain here. So first of all, what we need to do is to find the column shear. That means for these columns, so how many columns are there here? AE, BE, BF, CG, DH, EI, FJ, GK, HL. For all these columns, we need to find the shear. That means, first of all, we need to assume some value shear on this column. Here we have assumed P. Here 2P, here 2P, here P, here Q, here Q, here 2Q, here 2Q, here Q. If you see here, yeah, here Q, 2Q, 2Q, Q. So there are some assumptions in this portal method. So one of the assumption is, if we assume shear force P at ends of the multi-frame, and at the ends you can see P, in the intermediate columns, we need to apply double the force which we have applied at the ends. That means if we apply P here, 2P, 2P, because these are intermediate columns. If we have applied Q at the ends, so 2Q, 2Q. This is one of the important assumption here. So first of all, we need to calculate these P and Q values in this step. So for this, we have taken first story 2, the upward story we have taken here. So this is upward force. We have applied sigma fx equal to 0. So 20 equal to P plus 2P plus 2P plus P. From here, we have got P equal to 3.33. Then we need to consider the story 1. That means story 1, the downward portion. So here we need to consider, we need to apply sigma fx equal to 0 for downward portion only. Downward portion only. But we need to take these horizontal forces. Two forces we need to take here. That means if we apply sigma fx equal to 0, Q plus 2Q plus 2Q plus Q is equal to 40 plus 20, because this force effect will also be there on the story 1. Therefore both these to be taken. Here only upward force we are taking, but here while calculating story 1 we need to take both of this and q this one. Okay, this we need not to take, p2, right? So from here we have got q equal to some 20 value, some 10 value. Yes. So in step 2, calculating the column end moments. So column end moments means, so for all the columns we need to calculate the moments. That is, for ME, VF, CD, this one, this column, this column, this column, this column, we need to find the moments using the formula. Suppose AE is there, so here I have shown AE separately, P is there. So AE equal to MAE equal to P into half of the distance, P into perpendicular distance, that means 3.5 by 2. Similarly, we need not to take the external forces here. Yes, next here for BF. Yeah, so for MAE it is P into 3.5 by 2. P is 3.33 we have found in this step, so we need to substitute. So we have got the value as MAE as 5.52 kN per meter. Next DH, if you take DH, so force into perpendicular distance. So for all the columns it is the same. For intermediate columns, so force is 2P, therefore 2P into 3.5 by 2, 2P into 3.5 by 2. This is for story 1. Story 2. Next for story 1, Q into half of distance, 2Q into half of distance, 2Q into half of distance. 2. So from here we have found all the moment end columns. All the column end moments in this step. Yeah. In the next step, step 3, we need to calculate the moments in the beams. So what are the beams in the given question? AB, BC, CD, this one, AF, FG, GH are the beams. In these beams, we need to calculate the moments. In columns, we have calculated in the previous step. Now we need to calculate in the beams now. So what we have to do? So for first MAB. So MAB is equal to MAE equal to MAB. Next MCD equal to MDH. So this value we know. Therefore MAB, MCD is over. Now MBC we need to find. How to find MBC? Go to joint B. Okay. Now apply MAB plus MBC is equal to MBF. From MBF we have already found. This we have already found. Now we can find this easily. So you can go joint by joint. Here this MBC plus MCD equal to MCG. You will get, already we have found here. Okay. Next go to joint E. So MAE plus MEI is equal to MEF. From here we can find MEF. Coming to F joint, MEF plus MFG equal to MBF plus MFJ. From here we can find this value. Next come to G. MCG plus MCGK equal to MFG plus MGH. You can find this value like that. Here, so MDH plus MHL equal to MHG, like that. You can find in that way also. You can find this one. So in that way we can find the moments in all the beams. So next, calculation of shear in the beams. So beams are A, B, B, C, C, D, F, G, H. All these are beams now. So shear force in the beam equal to moment which we have calculated in the previous step divided by half of the length of that particular beam. So moment AB divided by L by 2. So here MAB is 5.82 and length is, so AB length is 4. Therefore 4 by 2. Like that. Next, shear in BC equal to moment in BC divided by this length divided by 2, 6 by 2, like that. So in that way we can calculate shear forces in all the beams in this step. Next, coming to step 5, calculation of axial forces in the column. So here we have calculated the shear forces now. We have to show the shear forces like this, which we have got in the previous step values. So upwards, downwards, 2.41, 2.41, 1.94, 1.94. Next to 2.41, 2.91. This value 2.91 upwards, 2.91 downwards, upwards 14.16 upward, downward, upward, like this we need to show. Next, calculation of axial forces in the columns. So in each column we need to calculate the axial forces. For this we need to take these 4 columns separately. First I am taking AEI. So in AEI, so I will show like this. I will show up to this one. These forces upwards is there now? Yes. So now axial force in the in this is nothing but sum of the two. One second. So axial force in AE, first axial force in AE equal to only upward force we need to take 2.91 Next, axial force in EI. We need to take both the forces, sum of these forces, 2.91 plus 14.66. We will got axial forces in EI is 17.07, like that. Next, take this column. So here we have this downwards, this upwards, here downwards, upwards. Show only these forces. Then, so for BF column, so this 2.91 greater minus smaller. Okay, 2.91 minus 1.94, so 0.97 downwards. Next, axial forces in FJ, so 2.91 plus 14.16, both we have to take, minus 1.94 plus 9.44, we will get 5.69 downwards. Next, similarly this also, for this column we need to take only this one, 2.91 minus 1.94 upwards, 2.97, and for this axial force in GK we need to consider this sum of this minus sum of this, so 5.69 upwards. Next, finally the last one. So here last one we need to show only these two forces. So axial force in DH equal to 2.91 downwards, axial force in HL equal to sum of this, so 17.07 downwards. So now we have got all the bending all the moments now, moments in beams and shears now. So we need to show those values for beams. We need, so here one of the assumption in this method is we need to assume point of counterflexure at the exactly at the center of the beam and center of the column. So you will get bending moment diagram like this. Values you need to write which you have got in the previous steps. It may be for beams MAB, MBA, like that. For columns here MAE, MEA, like that. So these values you need to write, and your diagram will be like this for all the beams and say columns. So this is your portal method problem. In the same way you can do the another problem also, like here you have 2-bay and 3-story problem. Same procedure you need to do for this also. First step is to calculate P, this P, 2P, PQ and R we have taken here, PQR. So for intermediate it is 2P, for ends it is PP. So QQ, 2Q, 2Q. So here we have to take only one force, here two forces, here three forces. Yeah. Next, calculation of columns and moments. That means this force into perpendicular, P into the distance half of the lengths or length of the column. So in that way we can find the MAD, so column end moments. Next, end columns means yeah, this is the same step, but 3 stories we have now, so 1 2 3. Next, calculating the moments in the beams. So at the ends it is same like this. So here also this plus this equal to this here, this plus at C at this joint, this plus this equal to this plus this, like that we can calculate the moments in the beams also. Next, shear force can be calculated in all the beams, moment divided by L by 2, L by 2, L by 2. Next, calculation of axial forces. So we have to take these three separately and we have to calculate like this. So axial force for this is this one. Here for this it is this one. For this it is this plus this. For this it is this plus this plus this. So in the same way for intermediate column, for this axial force is this minus this one, and for this you need to consider sum of these two minus sum of these two. For this you need to consider sum of these three minus sum of these three, like that. Yeah, thank you. This is about portal method.